Okay, this is the third video in our Creating Firefly series for Mesa. And where we left off last time, we had created a model that could synchronize these fireflies. And you can see after about 400 time steps, they are all blinking. All 200 of them are blinking at exactly the same time. And we can see this also if we add in the points. We can see these waves of these fireflies are syncing together and then they join somebody else. And these fireflies are all syncing together. They might be the main group, but another group takes over and everybody joins that big group of fireflies all blinking at once. So in this video, I want to make this more abstract from what I'm doing. I want to turn it into so I have some parameters to tweak in this model. Instead of, yes, it works, there's a lot of magic numbers. If we go back to what I was using in the description, we have created a firefly with a clock that lasts 10 time steps, and they are flashing on the first time step. We have created a 30 by 30 model with 200 fireflies, but we don't have the length of the cycle and the flashing length as parameters. And we don't have visualization yet. We'll do that next. But for right now, I want to say I have run an experiment with 500 time steps with the data collector, plotting my graph. And if I make it so it has parameters, I can change this so it has the first 2 time steps of the clock. Or I can run it so that the length of the cycle is 15 or 20 or something like that without having to go change numbers in my code so much. I have to change numbers when I instantiate the model. So let's go back to it and do those changes. First, let's make it so the cycle is not dependent on me as a firefly to remember, but is something the model should be remembering. We have a height, and we have a width, and we have cycle length. The default value is going to be 10, but I need to remember stuff. Up here is where I set my fields, I set my components. I can say cycle length equals cycle length. Self.cycle length is now available to anybody who wants to talk to the model. And who can talk to the model? The fireflies. So they get the model as part of what they can do. I can say self.cycle length right here. And, it's also down here in my clock. Self.get next, self cycle length. Those are going to be important. Okay, so before I go on, I have to say, wait, something is strange here. Firefly object. Oh, right, I should not say self.cycle length. The words I was saying, self.model.cycle length. Model. The model is the one that remembers it. The model has a cycle length. I have a link to the model, and the model is where I can talk to those. So let's try it out again. This is why I test my code often, because I often make small mistakes, and I don't want to run later and find everything wrong with it. Okay, great. Oh, this time they synchronized a little bit earlier, but it almost went, and now exactly about 489. They got there. Perfect. So that's one thing turned into a parameter. The second thing is going to be a little more difficult, excuse me, is the clock. So if I'm flashing at exactly time step 1, what if I wanted to make this variable? So somebody could have a parameter, again, in the model to say, I am flashing at time step 1, 2, and 3. Well, I want to make it 1, 2, 3, and 4. So I can't say, am I equal to 1? Let's make another model parameter. Let's make it called flash length. Equals 1. This is my default. And I remember it here. Self.flash length equals flash length. I could say return self clock equals self.model.flash length. But that doesn't really capture what I need to do. I need to do is my clock less than or equal to the flash length, because if flash length is 2, time step 1 and time step 2 should return true. So I can set it up like this. I am flashing if my clock time is less than the time marker of where the flash length starts and stops. Okay, now this is going to be tricky here. Where should I be? If I see someone else flashing, I need to be saying, I just flashed 2, and I just stopped flashing. So I am going to say self next is equal to self model flash plus 1. So if this is 1, this number is going to be 2, which is exactly what I had, but now it's much more abstract. Again, run it, make sure we didn't break anything. And there we go. It's a different one every time. This is a very random Monte Carlo infused model of what's going on with all the different choices of where they're going and how they're moving. But we got our synchronization again. Okay. Now I can start changing it with small pieces down here. I don't have to go write the code for the model again. I have to say, well, what if my length was 30? This is the cycle length. Let's see what happens. I am starting to see the synchronization, but it takes longer. And a test that I could run would be to say, how long does it take? Is the time that it takes to synchronize related to the length of the cycle? It probably is. There should be a nice correlation, and I could plot a lot more things to figure that out with the batch runner. I'm not going to do that. But we could also say, what happens if they have a length 2 for the time that they're flashing? Do we get some different behavior? And we do. We get them somewhat synchronizing. They're still changing all throughout it, but they are not getting together. They are not moving and flashing at the same time. And the reason for that is when I see someone flashing, I don't know if they are flashing in their first piece of the flash or the second piece of the flash. So if flash length is 2, there are 2 times on the clock when they're going to flash. But I see them flashing and I flash and say, I just flashed my second. Not all of them are on the second. And so some of them are going to be turning off and some of them are going to keep flashing. So I can't fix this in a nice way because it is unknowable to me exactly when they are flashing. So having a flash length that is small, 1 unit of time, that helps me narrow it down to exactly when they're going to flash. So this is how easy it is to run new experiments now with the parameters that we have. Okay, longer cycle makes it even harder for them to get together. Next video, we are going to go to the visualization to put this all into a 2-dimensional grid that we can watch the fireflies blink on the screen. We've got some good evidence that it is working in the agent and the model. We'll create a server and then get it all working in the Mesa environment.